I'm from the Kaizen Institute, based in the UK. And today we're going to talk about how metal forming can maximise operational efficiency using data analytics and AI, but really looking through it as a practical and operational lens. As you'll see throughout the presentation, this isn't really a technology presentation, but as we see, it's about how we can improve the performance in your operations and where data and AI can genuinely add value and where they do not add value. Check. So, continuous improvement. This is where it starts, and it starts with Kaizen. Kaizen comes from two words in the Japanese dictionary. It comes from Kai, meaning change, and Zen, for the better. Together, we see this change for the better and ultimately equaling continuous improvement. Now, our company as a whole is about continuous improvement in all aspects of business, and we believe this can be done every day by everyone and everywhere within the business. It's not just about big transformational projects, but if we can have these small, consistent improvements on how work is done, then we should see an overall improvement in the business from every single level. And ultimately, what this creates is just an organization that is much more resilient. Because instead of reacting to the disruption that we have, we're constantly looking for the improvements and constantly adapting to the change that we always see within various forms of life and within business as well. So before we move into the data analytics and the AI sections of it, I want to really understand how important Kaizen is to actually deliver within a manufacturing environment. Because to us, Kaizen is not simply a philosophy that we have. It really translates into measurable operational and financial performance improvements. And we see this over four key areas to establish within a business. Now, the first one we see is quality improvement, and especially within metal forming operations, quality is critical to both the customer satisfaction and obviously the company's overall efficiency. Now, we can see this through scrap, rework, defects, and variations that all drive the unnecessary cost and sometimes disruption throughout the production process. Now, within Kaizen, what we try to do is we try to help reduce these issues by really introducing some standard work that we have, improved process controls, and overall creating a greater consistency across every operator across the business. Now, ultimately, what we try to see from this is the improvements in first time right, reduce of scrap and rework, and more reliable quality that we deliver to our customers. Now, if we look at the second box here, we look at cost reduction. And for us, a significant proportion of manufacturing cost is driven by waste within the process. So how we break this down is we use an anagram called TIMWOOD. You may have heard of it before in a lean methodology, may have not, but overall what we look at is key areas within a process that we associate with waste. Some of these can be the waiting time, the excess inventory, the unnecessary movement of people, the machine downtime of what we have, overproduction, and then rework, all consume resources without adding actual value. Now, what we try to do is identify and systematically eliminate these sources of waste, and rather than reducing the cost through short-term measures, we try to see the profitability become more successful by really increasing the efficiency. So overall maximizing what you would say the resource utilization or the overall process performance. But what we also understand is that even within cost reduction and within waste, we sometimes cannot remove all waste. Some waste is necessary to the process. But what we can try to do is with our process improvements and trying to eliminate as much as we can is really minimize that to as little as possible. And by that, we're obviously going to start increasing the efficiency of the overall process. Now, our third that we have there is delivery performance. Delivery performance is driven by the ability to consistently meet production schedules, customer demands. We can have delays that are often bottlenecks, unplanned downtime, material shortages, inefficient planning. Sometimes it's poor information flow between functions or departments that travel through the business. And overall, what we try to do with the delivery performance is streamline the process and improve the operational stability. With this, we're creating a more predictable and reliable production performance, and in a whole to improve on-time delivery, shorter lead times for what we have, greater responsiveness to customer requirements or to issues we may have as well within the shop floor. And lastly, the one that we focus on a lot within our culture aspect of Kaizen is employee empowerment. Now, one of the main principles that we have as a business is to build high-performing teams. And the way that we can do that is the people closest to the process are often best positioned to identify the inefficiencies and are able to solve the problems that drive the main improvements that we want to have within the business. Now, Kaizen develops problem-solving techniques. We encourage it across what we would class as a tier 1 all the way up to a tier 4, tier 5, tier 6 of a business, to really engage with the teams, try and drive the performance from the shop floor level to the C level, and increase the operational efficiency across the board. Now, one of Kaizen's main strengths is the collaboration between departments. So we can have production, maintenance, planning, quality. Everything within these teams provides us a good base to approach problem solving and empower the people within these departments a lot more to start building on the techniques that we try to develop. And within that, obviously trying to increase the operational efficiency around it. So overall, what we try to install within businesses is that Kaizen wants to create stability, efficiency, and discipline within these teams to really have a structured approach within our operations. And overall, building that foundation can only be strengthened by the introduction of AI and analytics and real data analysis towards our operational goals. Now, before I get into the detail, I want to take a minute to frame what the session is really about and what is involved with what we want to discuss today, because this isn't simply a discussion about the data or the analytics that we want to focus on. But I would like to share with you some practical framework that we have that's built into a lot of our processes and a lot of our businesses today, that is trying to encourage them to be more efficient, resilient, and be more data-driven within a manufacturing setting. So how organizations combine the operational excellence and various aspects of it through Kaizen is with the capabilities of the data analytics and AI that provide sustainable performance and improvements. Within this, we have 5 key areas. And the first there is operational stability. And this is where we see everything really start within the business or the process. And we'll look at how Kaizen can strengthen the processes by overall reducing variation, potentially improving standardization of what we have, creating more predictable operational performance. Because without the stability and the discipline within these teams, and without that sustainment and what can be helped with AI, sometimes the execution can be a little varied. So to try and get the full spectrum across the business, it's a great tool that way. Secondly, where data analytics and AI create the value. So there's a significant amount of the discussion around AI, obviously. However, what we really want to see is, where does it create the operational impact? Where does it really become measurable within businesses? And what I'd like to do is explore where we can improve in some forecasting, planning, maintenance, quality performance, and equipment effectiveness to really drive what we want to discuss. And third, building data-driven teams. Now, everything has become very more advanced over the last couple of years. If it hadn't, we probably wouldn't be having this conversation. So it's always good to look at the scope of where we are and how we can start building it into our teams as well. And one of the main focuses of that is building the data aspect within our teams as well. With hope, we'll be able to discuss the capabilities across operational teams, and create the culture where decision is made by being data-driven. Now, we also have one of our key principles within Kaizen, that is, as well as empowering the people and having these conversations, it's no data, no discussion. What we want to see is we want to see the impact of what the problem may be. And the only way we can assess that is by really interpreting the data the best way we can. And then we can start to build on the ideas to try and increase the overall process to the best that it can be. Fourth, there we have the practical first steps. And one of the biggest challenges organizations face is knowing where to begin. So we'll review some practical actions that we can take in immediately, start to look at the data analysis and the AI journey without large-scale investment, without complexity, or the disruptions of everyday business. And then we'll bring together some to demonstrate how processes, people, data, technology, we really want to try and combine these to create this high-performing manufacturing operation that everybody wants. And there, what we see there is the integrated model on how processes, people, and technology combine into one sustainable operating model. So throughout today's session, I would like to encourage you to think about your own operation. Where are the biggest opportunities that you really see to improve performance, and where are the biggest constraints that limit you from doing so? And then overall, where can AI, where can be more data-driven really impact your operational efficiency or your operation as a whole and target to achieve the best results? So, reality in metal forming manufacturers today, we're seeing across the industry, is combining structural pressures that continue to intensify year after year. Importantly, these challenges they're not happening in isolation, and organizations are being forced to manage multiple operational pressures simultaneously. It's creating a lot of complexity across production, a lot of complexity across planning, and definitely across the supply chain functions as well. And we look at some of the key challenges that we see here first. The first is increasing product and customer complexity. Well, this creates commercial opportunities. It's also introducing significant operational complexity through increased changeovers, planned challenges, and variability in production schedules. Second, rising operational costs, labour costs. We have energy prices, raw material volatility, and maintenance expenditures continue to increase. At the same time, the competitive pressures really limit the ability to pass these costs directly to the customer, just with how things work as of today. And as a result, a lot of manufacturers are really trying to find their ways to improve the productivity, improve the efficiency, and to enable them to maintain the profitability of the business. Now, the demand volatility, customer demand's becoming increasingly unpredictable. And within a lot of different manufacturers, we are seeing some fluctuation more frequent than before in terms of batch sizes, or the planning horizons that we may have are becoming a lot shorter. And of course, this creates challenges for production scheduling, capacity planning, the inventory management that we see, and workforce utilisation on top of everything. And then increasing customer expectations. Customers are always very demanding. It never really changes, but we're expecting shorter lead times, a higher quality on top of what we have, greater reliability of the processes that are already in place, and then completing the real delivery performance of it as well. And the pressure on manufacturing operations is never been higher than what we've seen today, or greater, if you want. And now if you look at the typical impact of these pressures, it's really where the operational challenge becomes a lot clearer for us. And first, what we see is more inventory, but lower availability. We see more effort, but low productivity. And yet, despite the increased efforts, the output, the productivity can sometimes fail to improve. And in some cases, performances can actually deteriorate because of the more effort we are trying to put into the process overall. Now, organizations invest more in labour, inventory, overtime, corrective actions. And we see this a lot through a lot of organizations that we work with. However, it doesn't necessarily always translate into actually improving the throughput, improving the quality, or improving the overall customer service of what we actually want from the business. And I would say from what we see on a daily basis working with clients and companies, it's not the lack of effort that we see being a core issue, but it's the challenges of the complexity of the ever-changing models that we have within business and how they can consistently affect us to make decisions that don't necessarily improve the process overall. So from this, there's where the shift or the overall shift can come from. And the objective is not simply to work harder, but is to make better decisions, and how we make those better decisions through our operational efficiencies and our operation overall. And how we can do this is really be competitive and making advantages by making the advantages come from improving how the operation performs and overall how we look at it as a full concept, and not simply just increasing the effort or the work that has to go into it without a real plan in place and how we derive from that plan. So what we're now starting to see across manufacturing organizations is fundamental shifts, and a shift away from decision made after the fact based on yesterday's, say, production reports or downtime reviews or performance data, and towards decisions made in advance, supported by real-time operational data and AI-driven insights. If we look first at the traditional approach and what we tend to see, most decisions are based on historical performance information. Production teams review yesterday's outputs, maybe downtime, the issues within quality, our schedule performance, and then before deciding what actions we actually take. Now, the challenge is that by the time these issues have been identified, the impact has often already been felt. So sometimes we're not actually improving on our previous day's work, we're learning from it as such. And as a result, there's a significant amount of time reacting to the problem rather than looking at preventing the problem. Now, planning is also largely manual with what we have: production scheduling, maintenance planning, capacity allocation, inventory decisions, often relying heavily on, say, an individual's experience within the business or the judgment of others. And the experience remains extremely valuable. However, as operations become more complex, it becomes increasingly difficult to manage effectively through manual decision-making alone. And as a result, response to change can be very slow. And when demand changes, equipment fails, materials are delayed, or quality issues emerge, organizations often struggle to react quickly enough or adjust to become reactive or inconsistent, and this could be costly. Now, if we contrast that with an approach supported by data analytics and AI, the first shift is the prediction. And instead of reacting to demand changes, we're really looking to forecast them. And if we're reacting to equipment failures, predicting when the maintenance is required on these machines. And then instead of responding to the capacity constraints after they occur, we're actually trying to identify the risks before they even impact production. Now, this obviously enables a lot of better decisions to be made, and a lot of better decisions to be made around inventory, labour maintenance, the scheduling of production, before it even becomes an issue. And then if we look at the second shift of what we really want to see within organisations, is the second shift to optimisation. And that decisions are no longer static, if you want, that production schedules, maintenance priorities, inventory levels, resource allocation, they can be continuously optimized using live operational data that we have in our systems today. And then instead of fixing planned assumptions, organizations make dynamic decisions based on what's happening in real time, and overall looking to really challenge what we were doing previously. And then lastly, what we see here is responding faster to the change. So the last shift is really speed. And when conditions change, and they inevitably will, obviously, because the businesses are ever changing and the market is ever changing, alerts, predictive insights, and automated recommendations allow the team to respond immediately rather than waiting until issues appear in reports days later. So really, what we want to see is this is moving away from a reactive production management and into a much more predictive and proactive operational decision making. And because the manufacturer that outperforms their competitors are not always the ones that necessarily work harder. They are normally, or what we see today, the organisations that are making the better decisions at a faster rate and being a lot more consistent. So I would say that with how we are changing from the traditional approach to AI is that I wouldn't try and change the operational expertise that we have in teams with AI. I would simply use it as a tool to really enhance the operational expertise within the team. So being able to establish a clear connection with having the knowledge base of the people that we have within the business, and using AI as the tool that helps them along the way in order to support the business overall. Now, before we go into any more detail into the kind of data and the analytics side of AI, we really want to stress how important it is the reality of what we see across manufacturing industries. And over the past number of years, there's been a significant investment into a lot of digital transformation programs across lots of businesses in the last decade. We're seeing manufacturers invest a lot and heavily in ERP systems, EMS platforms, dashboards, digital teams on their own, a lot of automation, the AI tools, and advanced analytical teams that we also see. And sometimes the results have been underwhelming. And importantly, the reason is rarely the technology itself, but the issue often is the operational environment in which the technology is deployed in. So first, normally what we see is it's how technology is applied to an unstable process. From a personal point of view, we have been in many businesses where technology has been the forefront, and AI will solve their problems, or better data insights will solve their problems. And what we have seen is that a rush of implementation into an unstable process can actually make the process a lot more inconsistent to what we actually have. And it can be poorly controlled throughout the business. So overall, what we see is we don't actually eliminate the problem. We're simply, if you want, moving the waste of the process to technology and not necessarily within the team, which in itself can cause a bigger headache, if you want, within businesses. And then second, poor fragmented data sets. So automation systems are only as effective as the data that we support them with. And if we have poor data from production, quality, and maintenance records, inventory, or is inconsistent, they're spread across multiple disconnected systems, then the outcomes can be very unreliable. And when the outcomes become unreliable, competence in the technology quickly disappears. To give examples, a lot of the time we will hear, well, the old system never done this, so why can we not get the old system back? And what we're always told is that the new system is an upgrade in what we have, potentially because of the data that's been dragged in from the old system and what the legacy held from before is probably causing us a bigger headache now. Third, lack of standardization. Now, a consistent process within Kaizen is standardization. Now, standardization is a key pillar. And if we can standardize processes, we will see a massive change within the business, but we will see a small improvement as well within the operational efficiency. Even if it's a poor process, standardizing it the same way for everybody to do, we can then have a better efficiency across the board. But within this, what we see is that the consistent processes that we have, there's no meaningful baseline what to measure the performance on. And it really becomes difficult to identify the improvement opportunities from that. And if we compare the performance across shifts, as I'm saying, or the sites, or how we train the predictive models effectively, then we can see inconsistent points to the process that we didn't see before. Now, fourth, no ownership. of the performance. And often digital tools introduced sometimes lack the clear accountability within a business. Dashboards are built, the reports are generated, systems are launched, but nobody owns the actions or the real care for what we have or what actually comes of the insights as well. And as a result, the tools are initially adopted, but then they gradually phase out. And this standardization it kind of goes back to the last point. Having no standardization within a lot of processes means that, you know, we see a lot of the processes getting left behind, but the technology advancing. So many systems are deployed separately from the way production teams actually manage the operation. And the technology will exist, but the data doesn't, and it doesn't influence the daily decision making. Behaviors don't change, performance doesn't improve. And if it brings that together into one very simple message, it's that technology cannot fix broken processes, but what it can do, it can amplify them. So what we see within this is more because technology is applied to standardized processes that has reliable data and disciplined management systems, that's when organizations begin to realize the full value adds of the data analytics and AI. And the technology that we're using really becomes an accelerator of the performance overall of the business, rather than a new tool that will replace the operational excellence model that we will have in our businesses today. So this is probably the most important concept in the entire session we have, because this is where many digital and AI initiatives either succeed or they can fail. And if we look first at what Kaizen focuses on in practice, there are 4 key areas. And the first area is eliminating waste, as I said. So in metalforming environments, obviously waste appears in many different forms. And I touched on this earlier. It can happen within the material, the waiting time, the handling of the materials, the rework, the machine downtime. And what we try to do within Kaizen is systematically identify and remove these non-value-added activities, trying to install a leaner, safer, more productive operation within the business. Second, we focus on the standardization of the workflows. So creating repeatable documented methods for operating equipment, performing setups, conducting inspections. And then regardless of the shift, the operator, we're really establishing a more standardized way of work across the business. Third is creating flow, reducing these interruptions, minimizing the bottlenecks, ensuring material runs smoothly through the value stream. This enables us to single out where the inefficiencies are and solve them to create a more flow, stable state of what we have. Improving the flow overall, what we're trying to do, reduce the lead times, increase throughput, and then delivery performance. And then lastly, what we see there is making the performance visible is the fourth focus, and using real-time operational data to make performance transparent to every level of the organization, whether that's OEE or downtime, or the scrap that we have. Then the objective is really simple. If you make the problems visible, then they're more quickly to solve. And we believe this is where Kaizen begins to connect directly with the data and the digital technologies. Now, if we look at why this matters, we see clear links. We see clear links within the AI, and what we see within that is the stable processes enabling a consistent operations, generated structure, trustworthy operational data is a natural byproduct. Reliable data, clean, consistent data, enabling analytic teams to identify the genuine patterns and make confident decisions. And then the effective AI is the AI models trained on reliable data produce accurate predictions and a meaningful optimization. So really, stable processes leading into reliable data means effective AI. And this leads us to the very important recommendation that we see is that we don't start with AI, we start with stabilizing the operation, and then we use AI as the byproduct to really help us increase the speed of stabilizing the processes, inputting the reliable data, and using it effectively. So within this, we have the integrated operating model. And I'd like to try and bring everything together as much as I can, because the sustainable performance improvement does not come from a single initiative. It doesn't come from one technological investment or just one improvement project. It comes from the entire operating system working together and cohesively. And what we consistently see is high-performing manufacturing organizations that are long-term success. They do it within three elements. They do it within the process, they do it with the people, and they do it also with the technology. So if we look at the process, this is the foundation of our operational excellence model. And what we need is stable, standardized production processes that deliver the quality and the productivity that we need to deliver performance. And we need to clear operational measures, define ownership, our visual performance management within that. And this has to be done at every level of the organization. And then what we need to do is eliminate the wastes and embed the new process into daily operations. And then because without the stability, the variability increases, the performance becomes unpredictable, and the improvements become difficult to sustain. But if we're able to clean the process, then we are able to target all of these things within the business. Second, as we've mentioned before, is the people. And ultimately, the people is what drives the performance. We need operators, supervisors, engineers, and managers, in a sense, to understand the data available to them and how we can use this to make better decisions within our manufacturing realms. And for this, we have the structured problem-solving capabilities that we build into our daily management routines. And we also build the culture where continuous improvement really forms. And as I said before, we believe it's every day, everywhere, by everybody. So everybody is responsible. And we have maybe dedicated improvement teams working on various different aspects of the process to ultimately target the flaws in it. So the third tier that we have is the technology. Now, technology, as I said, we have to use this as the accelerator. And data analytics provides visibility in production performance, reliability, quality trains, operational bottlenecks, and really the machine learning support, prediction, and optimization that it can provide can ultimately help us in trying to increase the quality of the forecasting or the production scheduling or even energy management, for example. But it's important to remember that technology should support the decision making, not replace it, as we've already touched on the previous slide. Now, strength in one area, it cannot compensate for a weakness in the other. You can invest heavily in the technology side, but again, if your process is unstable or the people aren't committed to what we want to do or engage within the process, ultimately we see it fail. That's clearly why we need process, people, and technology to work together as a team, just like the teams on the shop floor or the teams in management will do, to really build this dynamic, integrated operating model that enable us to improve our efficiency. Now, if we kind of take a step back and I look at where the data and the AI actually creates value across our manufacturing operation. Because one of the most common misconceptions that we have, especially with AI, is that it creates value in isolated areas. In reality, its greatest impact comes from connecting the decisions across the entire production value stream. And if we start on the left-hand side there, we look at demand, and everything begins with understanding future customer requirements. And as I said, AI can improve in our demand forecasting. It can analyze historical orders, maybe customer behaviors, the market trends that we see and the production patterns that we have on a daily basis. And the benefit is greater visibility of future demand is going to enable us to make our decisions earlier and with greater confidence. So instead of reacting, we're basically preparing them for the business. The second one we have there is inventory. And the challenge is not simply what material to hold, but it's how much to hold, and when to replenish it, and what is our maximum and minimum levels that we have within the business, and where it should be positioned within the business as well. And maintaining material availability while minimising excess stock and working capital can obviously improve both the operational flexibility but the financial performance of a business as well. And then that drives to what happens in the production and warehouse operations as well. When demand and inventory requirements are visible, we have the labour planning, machine loading, production scheduling significantly more effective. And AI can help optimise all three across the chain to really identify the bottlenecks that we see and how we can affect or how we can challenge them to improve the operational efficiency. Lastly, the last two that we see here, we have delivery and logistics. And the ones the products are manufactured, we can optimize dispatch planning, transport scheduling, delivery routing, ultimately trying to reduce our costs within our transportation. And we would like to think that reducing our costs within our transportation and improving on our delivery routes, or say we're ultimately giving the customer a better experience and really increasing the service performance KPIs that we will have in the business. For example, on-time delivery or on-time in full, if anyone tracks that as well. And then the customer. So data can be used to identify the change in demand patterns, the service risk, the priorities that we have for future growth opportunities within the business. And this allows the organisation to become much more proactive in how they manage the customer relationships, and also how we look at the service performance as well within the business. So, as I said before, I'd like to do now is try and make this much more practical, because we talk about data, we talk about AI, and the question most leadership teams ask is, where should we actually focus? And across manufacturing, metal forming operations, there are 4 areas where we consistently see the highest impact. And importantly, these areas are where the outcomes are clear, they're measurable, and they also directly link to that operational performance that we seek. So first, we see demand forecasting and production planning. Now, this is typically where many manufacturers begin. And the key decisions are, what do we need to produce? And when do we need to produce it? And how do we align the production capacity with our customers' demands? And what we can do with AI, we can analyse historical orders, customer demand patterns, seasonality, and production constraints to create more accurate forecasting and production plans within that. And overall, the result is better capability, better capacity utilisation within our capabilities, which ultimately should see future schedule changes and improve material availability and higher on-time performance for the delivery also. Now, the second we have there is the production productivity and process optimization. And this is where we see it directly impacting on our shop floors. And what we see is a lot of metal forming operations. They have constraints, we have bottlenecks. We don't see it only in metal forming, we see it in a wide range of businesses. And sometimes we see a loss of productivity due to this. And really, by analysing the machine data and the production performance that we use in everyday activities, we can identify the opportunities to really improve the throughput and reduce these inefficiencies. And with that, it's optimising maybe the machine sequence, or really not only targeting how we can reduce the changeover at all, but how we can reduce the changeover losses that we see within that. Maybe it's the planning of the jobs, or the planning of the material better, so it's less changeovers rather than speeding up the changeovers as such by using a simple SMED. And ultimately, what we try to see and what we try to impact from this is really a higher productivity by increasing the throughput. So basically, having a better utilisation of our existing workforce that we have today. Third, the predictive maintenance and equipment reliability. Obviously, quality is a key aspect of what we have as well, and I'll touch that on the last, but without real equipment reliability, sometimes this can lack in what we have. And what we see is maintenance activities that either react or they're based on or a fixed schedule. Now, what we try to do with AI or within businesses is allow organizations to move more towards a predictive mindset. And this is by analysing the machine's conditions and the operating parameters with historical failures and potential issues that have been identified during breakdowns, etc., to try and enable us to intervene proactively within the schedule of the machines to have a higher reliability of the product, or the machine, sorry. And then fourth, the quality prediction and process control. So the statement there says reduce scrap and rework by identifying process conditions that drive defects and quality variation. And what we're trying to see with the AI is how can we identify the process conditions that increase the likelihood of quality issues? And this allows us to take the corrective action before defects are produced by analysing production parameters, some machine settings and tooling performance, and looking at the historical quality data that we have within our data sets and seeing how we can improve on the controls and the variations, reducing the variations, overall of our quality of our product. So, because I would say we have spoke about the AI and how it can really help within businesses and where to focus within it. But in practice, the manufacturers that succeed in the space are not necessarily the ones with the most advanced technology, but again, the ones that build the right capabilities within their team, as we've touched on in some of the previous slides. And as I said, technology alone does not create transformation. And even the most analytical platforms will deliver very little value unless the people using it have the capabilities and the real confidence of what we want to achieve with it. And not only the confidence, but the discipline and how we want it to be carried out. Now, from what we have 4 key areas that we look at. First, data literacy. Teams need to be able to read and interpret the data, not just view it on a dashboard, but actually diagnose what they see from the information provided and actually have some creditable reasons to either target a specific area or really have a better insight into what we're looking for. Leads me on to the second point, which is the problem solving. And this is where we take the data literacy and what we're seeing from it and really changing it into an action. And the one thing to identify from the data is, yes, the performance has dropped, but it's a completely different aspect of it to really understand why has it dropped. And how can we build these structured problem solving teams to have a more recognized focus on identifying root causes and implementing sustainable corrective actions that are either going to solve the problem or identify our quick wins so that we can have a longer solution and the kind of longer term aspect of the business. Now, it's particularly important in manufacturing environments such as downtime, quality defects, scrap, some delivery days. They can have multiple contributing factors. So it's understanding that not only how do we solve the problem, but then how do we simply react to the problem as well that's been given within the data. Third and fourth, so the third one we have operational understanding. And data only creates the values to understanding the context of the operation. The teams need a clear understanding of how material, the information flow, and the workflow all flow through the business. From customer demand to the planning, through the production scheduling, the operations, the quality control, maintenance, and so on. Without the operational understanding, it becomes very difficult to interpret the data. And this means that we may get actions that might not be the right ones or might not be the best ones to take forward and could hinder us in the future process. And lastly, everything is great about building the data-driven teams and using AI, but without identifying a real continuous improvement mindset and changing the business into this mindset, we will struggle to sustain all of the first 3 that we have. Because without the continuous improvement mindset, yes, I can read data great, but then how do I challenge the data and the problem solving? How do I then solve the problem to have the better operational understanding? And then how do I consistently do that? on a continuous improvement basis to consistently look for the next opportunity to improve our process overall. So what I have here is from data to continuous improvement, and I'd like to try and connect everything that we've discussed back to our shop floor improvements, because the data only transforms performance when it becomes part of how the real factory operates in that every day. So by that, I mean, it's not just a report, it's not just as a dashboard, but it's as part of the daily management routines that we see within the business. And first, it comes from the monitoring KPIs in our dashboards. And really, it's ensuring everyone understands how the operation is performing in real time. Because if the performance isn't visible, it can't be managed effectively within that. Secondly, identifying the problems and the deviations. And the key is identifying these deviations early, because small problems rarely stay small for long in a manufacturing environment. A lot of the time when we have a small problem, maybe we, if you want to use the term, you put a plaster over the problem, and sometimes it doesn't stick. And there you are with a larger problem that is impacting your manufacturing operation a lot more than you thought it was going to at the start. Third, investigating the root causes. And the goal is really to understand why performance is below target, because unless there is a root cause to be addressed, the problem will just continue to stay there. Fourth, implement improvements. Now, I want to try and remove the bottlenecks from production flow, and the focus is always on fixing the cause rather than treating the symptom. And then fifth, track results and sustain gains. The final step is confirming that the improvement has delivered the intended results that we wanted to see. So overall, it's really having the improvement statements of, has the OEE improved? Has the downtime reduced? Has scrap decreased? Has our throughput increased? And if this improvement is successful, it's standardized into normal operations, then it ensures the benefit is sustained over a larger or a longer period of time, and even gradually disappearing as it goes in if it's not disappearing at the start. So where do we actually start, and how do we start with AI? So for many manufacturers, this is where things become clear, they become sometimes complicated. And what we consistently see is the most successful data and AI programs, they do not begin with the technology, but the clear understanding of the operational problems, and especially the problems that we need to be solved. And by that, we look at three key steps. So first of all, we look at making the data more visible. So most metal forming businesses will have large data sets, and I'm sure everybody on the webinar today will have a large data set of various different touch points across various different systems or platforms. And the challenge is that the information is often fragmented across multiple systems. Sometimes we do not have this single source of truth that we sometimes seek. And the goal is to not build hundreds of reports or have a daily email chain that gets logged out every single day, but really create the visibility in one location that everybody is able to try and follow and build a foundation from. The next is identifying the high impact problems. And then this is when once we see the problems becoming visible, the next step is identifying the biggest opportunities. So where do we have the highest downtime to target? What are the changeovers impacting capacity the most, for example? And what we want to seek from this is to quantify the value of solving each problem. Because what this does is it allows us to prioritize our large problems and build a clear business case for investment. And not only that, but enabling us to target to solve the biggest problems for potentially the operator on an everyday scale. And step three we have is pilot and scale. So the third step is to really send out the pilot of the solutions that we have in a controlled environment. Normally what we tend to do is we tend to start small. We maybe select one line, a specific machine group, for example, or a product family. And because when we are able to do this, we're able to deploy the technology across the business a lot easier. and at a better rate, if you want, than rushing everything in. As I touched on before, something that we do tend to see is that we rush a lot into the technology and don't actually have a clear plan or pilot to scale it up across the business. So before we close, I'd just like to discuss that it's important is the opportunities, that the understanding why so many AI and digital transformation initiatives fail to deliver the results across organizations. And across manufacturing, we see very similar patterns, and understand these mistakes is one of the fastest ways to improve our chances of being a success. So what typically goes wrong is the first and most common mistake is starting with technology. And companies investing in the AI platforms or the analytical tools or software solutions become very clearly defined that the operational problems that they're trying to solve. But the discussion becomes about the technology rather than the business outcome, if you want. And when that happens, the projects often struggle to really demonstrate the value of what we seek. The second is issues of the poor data quality, incomplete production data, inconsistent downtime coding, missing quality records, different versions of the truth across departments. And as we discussed throughout the session, AI is only as good as the data that it's provided with. And if the data is unreliable, the outputs will be unreliable too. So we really need to strive to have that good quality of data within the system. Third, lacking of ownership, no accountability, no clear sponsors within it, individual responsibilities for driving, say, adoptions or embedding the changes. As a result, some initiatives lose momentum just normally. They can sometimes become another unused system. To give an example, a business that we had been working with recently had 6 different fragmented systems that were all carrying separate pieces of data, but there was no real link. So how they had to manage the link was very inconsistent. Now, in order for us to assist and really build on AI, what we tried to do is we tried to overall look at the full process of the information flow, and we had to piece by piece build a system and build an overall tool that can help piece their systems together, ultimately to really drive the data quality to a good standard. Now, the fourth mistake we see, AI as a black box, if you want. Operators, supervisors, managers not understanding how to recommend on how the recommendations are generated, if you want. And if people don't trust the outputs, then we simply won't use them. Finally, there is often no link to daily operations. So the technology may work perfectly, but if it isn't integrated in production meetings, shift management routines, used effectively within these daily meetings that we have every day, then the behavior doesn't change, the performance won't change. So when we actually look to what works, it's first, we start with the operational challenges, reducing the downtime, improving the OEE. We invest in clean, reliable data, standardise data collection, improve data accuracy, establish confidence in the numbers through the teams. We then involve the frontline teams from the beginning, so operators, team leaders, and engineers, maintenance technicians, planning, and then finally we use the AI to support the decision making. And rather than trying to replace it, it's helping us identify the patterns that we want to target, predict the outcomes that we want to see, and recommend the actions that are going to take us further within our operational efficiency. So the last warning sign there is kind of what we've touched on the full time, but AI has to be seen as an enabler. To say that it's a solution on its own would not be fair, because without everything that we have touched on what works, we simply won't get the benefit from it, and we'll be rushing into solutions that won't work. Lastly, so this is the last slide I would like to close on, and it's how our Kaizen approach to AI. So the journey towards really becoming a truly intelligent manufacturing organization it's not simply the technology investment, but it's this disciplined progression that we see within it. And that progression always starts with the operational excellence model that we have. So if you look at the left-hand side, this is where the journey begins. We first have to stabilise the process. We second have to eliminate the waste. We then have to standardise the workflows. We have to make the performance visible, deploying the dashboards, implementing them within daily routines, understanding what the team wants to do and what the team is aligned to do. And then from there, we apply the data and the AI. And only once this foundation exists do we move over to this section that I have on the right-hand side. And with stable processes and visible performance, data can now start supporting the decision-making within the business and really helping teams identify trends, understand the performance losses, and ultimately responding faster to the issues that we see. And then using the reliable, historical, and real-time manufacturing data from AI to predict equipment failures, maybe predict the bottlenecks that we see within production, optimize the scheduling, reduce downtime within some of the lines as well, and overall really improving our overall equipment efficiency or equipment effectiveness, if you want. Because AI performs best when it learns from the stable process and the reliable data. So, as I said, if I was to leave you with the sequence of what we really try to install and see within businesses, is that we first have to target our Kaizen aspects first. Then we have to use the data built from our stable processes, and then use AI to generate our tools and decision making to really understand how to take the business forward. So what I would say is, when you get the sequence on the right, you don't create isolated improvements, you create the system. And then when the system is there, the operational excellence and the AI is just reinforcing it to each other. And we're better processes, we create better data. With better data, we're enabling better decisions. And better decisions are ultimately hoping to come from our AI. So again, let's not try and start with AI. Start by building our manufacturing operation that is ready for AI, because this is really where the value is able to be unlocked. And that is the final slide there. So as I said, this is our website. And if you would like to learn any more about our support in these initiatives and organisations, and how we've really achieved operational excellence within metal forming, for example, or any other industries that you would like to take a look at, you'll be able to access them on our website here. If anything that I have spoke about today, and you would like a specific case study forming around that specific topic, then please reach out. My email is in the bottom right hand corner there. I'll get back to you as soon as possible, and I'll be able to give you a more in-depth case study based on any of your questions.